Hello. In this video, we're going to go ahead and graph the quadratic function following the steps from the previous video. Okay, so what we have is we have f of x equals 2x squared minus 4x plus 5. To graph this, the first thing we want to do is we want to find whether this function opens up or down. So the first step is to determine up or down, and to figure that out, we look at the leading coefficient. Notice that we have x squared, x, and no x. That's exactly what we need. So the leading coefficient is the coefficient of the x squared term, which in this case is 2. So since 2 is positive, that means that this function is opening upward. Excellent. In other words, it looks something like that. Wonderful. Now that we have whether the function opens up or down, let's look at the vertex. So to find the vertex, we need to use h equals negative b over 2a. In this case, a is 2, b is negative 4, and c is 5. Plug these two values into the function, and that's going to give me the opposite of negative 4 all over 2 times 2. Opposite of negative 4 is 4. 2 times 2 is 4. 4 divided by 4 is 1. So it tells me that f of 1 is equal to 2 times 1 squared minus 4 times 1 plus 5. By the way, if you need to, just type this into the calculator. There's no need to guess as to what the actual value is going to be here. 1 squared is 1. 2 times 1 is 2. So this entire thing here is 2. Negative 4 and positive 5. So negative 4 plus 5 is 1. 1 plus 2 is 3. So that means that f of 1 is equal to 3. Excellent. So that tells me that the vertex in this function is the coordinate 1, 3. In fact, I'm going to go ahead and plot that coordinate on the coordinate grid. So go right 1 up 3, and there is my vertex. Excellent. The next thing we need is the axis of symmetry. And the axis of symmetry is always going to be x equals a number. And that number is the x-coordinate of the vertex, in this case, 1. And we're going to go ahead and draw the axis of symmetry by doing a vertical dotted line at x equals 1. Fantastic. Now that we did that, we want to go ahead and find the x and the y intercepts. So, whoa, what just happened? That was weird. All right, oh, there it goes. That's better. Anyway, so to find the y-intercept, let's go ahead and find the y-intercept first. We want to find f of 0. In other words, plug all the x's in to plug in 0 for all the x's and simplify. That's going to give us 2 times 0 squared minus 4 times 0 plus 5. And the great thing is that any term that has a 0 in it goes away, and we're just left with this constant at the end, which just means f of 0 equals 5. So the y-intercept in this case is the coordinate 0, 5. And I'm going to go ahead and plot that. So 0, 5 is right here. But notice that by knowing 0, 5, I can go ahead and plot 2, 5 as well. Because if it's 1 unit to the left of the axis, there has to be something 1 unit to the right of the axis as well. Fantastic. As for the x-intercept, notice that there are no x-intercepts, because if we were to graph this function, notice that we are opening up, and at the vertex we're going up. Therefore, this function never crosses the x-axis. Therefore, there are no x-intercepts. Outstanding. And I kind of went ahead and just did number 6 here as the graphing of the parabola. And that's the fantastic thing. I didn't need another point because I had the vertex here and I had the y-intercept, and because we know that the axis of symmetry, that means that we have another point right here, which gives me what the parabola should look like. By the way, always try to make this smooth. Remember, polynomials are smooth and continuous. Alrighty. For the last step here, let's talk domain and range. First of all, domain, always negative infinity to infinity. The range, we start at the vertex and go up, and the vertex's y value is 3. So the range, start at 3, go up to infinity, include the 3, exclude the infinity. By the way, notice that 0 does not exist between 3 to infinity. That's the reason why, another reason why, there is no x-intercept. So only if the range includes 0 somewhere in it will you ever have an x-intercept. And also remember, you will always have a y-intercept because 0 is included in negative infinity to infinity. Alrighty. Well, I believe that's it for this particular video. I already showed you how you can graph these in my math lab. It's really not that hard. Just be sure to graph the vertex and then any other point. Alrighty, well, I will go ahead and see you in the next video. Have fun.